right, we have a pendulum that what's a pendulum? Here it is. Here's a pendulum. Something that goes back and forth like this. Yeah, the grandfather clocks have pendulums. There's all sorts of different types of pendulums. We have theta, basically theta of t is equal to 0.2 cosine of 8t, where t is angular displacement. Well, theta is the angular displacement from the vertical in radians, and t is time in seconds. And I'm going to use that equation now. First off, it asks for the maximum value. Anybody get an answer for the maximum value? Almost. 0.2. Now, if I said the cosine of 8t, I don't know what that is, but it's going to be between two numbers. It has to be between two numbers. What's the lowest it could be? What's the lowest the cosine can be? -1. What's the highest it can be? 1. So at the highest value, this is going to be a max. So if I take that 0.2 and multiply it, basically what's going on here is figure out the max. 0.2 times the maximum of the cosine value. So what's the maximum of the cosine value? 1. The 8t doesn't even play into it because that's just an angle. So the max is just equal to 0.2 times 1, which is equal to 0.2. Now, first off, does that make sense with the cosine function? The cosine, the highest value cosine can ever be is 1, so the highest value times 0.2 is going to be a 1. Since that's a fraction, then we're going to multiply it by another fraction. You end up with an even smaller fraction. A fraction of a fraction is a smaller fraction. So our maximum value is 0.2. Well, think of the unit circle. The cosine here is 1, 0, -1, 0. Then back up to 1, 0, -1, 0. It doesn't matter what the angle is. It's always... Cosine of pi is going to be -1. So the value, the maximum value that it will ever take is 1. Well, sine and cosine, it's always going to be, the sine and the cosine is always going to be between -1 and 1, no matter what the angle is. It doesn't really matter. Tangent does like this. It goes on forever, so it can have a maximum or a minimum. Yeah, or it doesn't have a maximum or a minimum. It could go to infinity or negative infinity. So usually if you're dealing with a tangent, you're going to be dealing on an interval. So you might have to check out what's the maximum value on the interval. And that's when you type it into the calculator usually, if you can, and figure out the maximum. We're gonna figure out a way to calculate maximums by taking derivatives, so don't worry about that. And you guys are just like, oh, joy. I saw it in your eyes. I've seen that look before. Yes. If it was 10 times the cosine of 8t, the maximum is 10. That's as big as it could ever get. Yes?
So, since what's the minimum it can possibly be? Would it be -0.2?
It would be -0.2. Alright, now, the rate of change. This is the part that seemed to, well, I don't know. I didn't get to talk to anybody but one. The rate of change what chapter are we in calculus? 2. What's the name of the chapter? Differentiation, derivatives. Is there a cuckoo bird out there? Or maybe a dodo bird. The rate of change of any function can be found by the function's derivative. So, if we need to figure out rate of change of a function, which is kind of like slope of a function, derivatives are our key. Derivatives are going to give us a function that can let us calculate the rate of change of a function at any single point. So I need to take point 2, take theta of t. I just changed it to theta of t. You could have kept it as theta. Doesn't really matter. I need theta prime. Sounds like a transformer. God, you guys are tough. Tough crowd. All right, you got point 2. What's the derivative of the cosine? Negative sine of 8t. Now, is this t? No, it's not t. So what rule? Chain rule. Chain rule times 8. So what's 8 times 2? Well, what's 8 times 2? 16. It has one decimal place, so we move the decimal place over. It's 1.6. Now, is it going to be positive or negative?
Positive.
Oh, negative.
Negative, because it was negative sine. So it's negative 1.6 times the sine of 8t. Now, the problem says, what is the rate of change at t equals 3 seconds? So I need to find theta prime at 3. You always take the derivative first and then plug in numbers afterwards. So now we get negative 1.6 times the sine of 24, and make sure this is in radians, or else you're going to get a weird number. So yeah. So I'm going to start a new document, and that didn't do anything. 150. Store. I don't know where I got it from. I ordered it from something. I think I ordered it from Texas Instruments itself. Alright, so I want to make sure that I'm in radians. So I'm going to go to settings, go to, I think it's document settings, and I'm in degrees. See, I would have messed it up. I'll put it in radians because I want that to be default. So make sure that you put everything in default, and then when my wonderful geometry kids have to use degrees, I'll tell them how to actually type in 35 degrees. So it'd be okay. So I'm going to try this again. No, I want to make, and this is all just making sure that everything's okay. So I want the calculator. You do the never mind. It'll work. Negative 1.6 times, I need the sine of 24, 1.44893. So I'll say theta prime of 3 is equal to 1.4, we'll go 2 places, 1.45. Now, it is going to be in centimeters per second, because it's a 15 centimeter pendulum. So I'm going to basically no, actually, you know what? It's theta. Theta's in radians. So this is actually radians per second. So sometimes whoops, there you go. Since the problem said that theta is in radians and everything we're using is in radians or we're using a time, we keep this in radians per second, which means it's talking about the rate of change of the angle. So it's changing at 1.45 radians per second, which is pretty quick because if you think about it, to go all the way around the circle, how many radians is it? 2 pi, which is 6.28. So it's about 1/6 of a circle in a second. So for a pendulum, that might be pretty good. Like 1,000, maybe not, I don't know. It might be a really slow pendulum. But here's two big things, and this is why I wanted to talk about this. One, this idea right here. If you want maximum and minimums and you got your sines and your cosines, remember the maximum that a sine could ever be is 1 and the minimum that the sine can ever be is -1. So keep that one in your craw somewhere, in your noodle, in your noggin. And also this big monstrous idea. This big monstrous idea is whenever you get a function you want its rate of change, derivative. Take the derivative, plug in the value after the derivative. Because if you plug in the value, you're going to get a number. What's the derivative of a number? I'm just making sure that's not contraband. If one goes on the floor, so help me, I'll cut your hair off. All right, sounds good? Now, does that problem make sense after you see it done? All right. And it came from two basic ideas. Two basic ideas. The maximum of a trig function and knowing the sines and the cosines and understanding them, because you're never going to get away from them, and I guarantee you on the AP test there will be sines and cosines, and they probably will ask for maximums and minimums. So this is something that you'll see a lot of. And also, that idea that the derivative and the rate of change are married together. They are one and the same. The derivative is just the fancy calculus way of saying the rate of change of a function at a point. Or the rate of change of a function at all points. That's what a derivative is. Bien?